A star is born. Our sun ignites. Imagine a giant cloud of gas and dust floating in the vastness of space. This cloud was enormous, much bigger than our entire solar system is today, stretching across light years. It was slowly swirling and spinning in the vast emptiness of space, a cosmic dance that would set the stage for something spectacular. Over millions of years, gravity, the invisible force that holds the universe together, started to pull everything in this cloud towards the center. As the cloud collapsed under its own gravity, it got hotter and hotter, the pressure building up in the core. The center became so hot and dense that atoms began to fuse together in a process known as nuclear fusion. This fusion process released incredible amounts of energy, and a star was born in a brilliant burst of light and heat. Our very own sun had ignited, flooding the surrounding space with light and heat, marking the dawn of a new era in our cosmic neighborhood. But the sun's birth wasn't the end of the story. It was just the beginning. Leftover gas and dust still swirled around our newborn star, creating a chaotic but beautiful scene. This remaining material would eventually coalesce to form the planets, moons, and asteroids that make up our solar system, each with its own unique story and characteristics. Dust bunnies of space planets begin to form. In the vast expanse of the early solar system, a fascinating process was underway. The leftover gas and dust didn't just sit still. Instead, it danced and swirled, creating a mesmerizing cosmic ballet. It continued to spin around the sun like a giant cosmic whirlpool, drawing in more and more material. As this material circled the sun, tiny particles began to clump together, sticking to each other through static electricity and other forces. Think of it like dust bunnies forming under your bed, only on a much grander scale. These clumps grew larger as they collected more particles. These little clumps of dust and ice acted like tiny magnets, pulling in more and more material from their surroundings. They attracted more and more particles, growing bigger and bigger over time, eventually becoming sizable chunks of matter. Some clumps grew so large that they became planetesimals, the building blocks of planets. These planetesimals collided and merged, forming even larger bodies. The inner solar system was a hot place, close to the sun's warmth. Here, mostly rocky planetesimals survived, enduring the intense heat. Further out, where it was colder, icy, and dusty, planetesimals thrived. These regions were far enough from the sun to allow ice to remain solid. In these colder regions, planetesimals could grow larger and more complex, incorporating both rock and ice into their structures. Our Earth was one of these growing worlds, a young planet in the making. Over millions of years, it would gather enough material to become the vibrant, life-sustaining planet we know today. Earth takes shape, a ball of rock and fire. Imagine the early Earth. It was a hot, molten world, constantly bombarded by asteroids and comets. These impacts generated immense heat, keeping the planet in a mostly liquid state. Over millions of years, Earth began to cool slightly. Heavier elements like iron and nickel sank towards the center, forming our planet's core. Lighter materials like silicon and oxygen rose to the surface. Volcanoes erupted across the young planet, releasing gases from Earth's interior. These gases would eventually form the early atmosphere, a thin veil compared to the air we breathe today. Earth was a violent and dynamic place, but slowly, it was becoming the planet we know and love. Cosmic crash course, impacts from every direction. The early solar system was like a crowded dance floor, with planets and smaller objects constantly bumping into each other. Earth, still in its infancy, experienced its fair share of collisions. Asteroids, some the size of small cities, slammed into the young planet. These impacts released enormous amounts of energy, melting rock and sending shockwaves across the globe. While these collisions were destructive, they also played a vital role in Earth's evolution. Asteroids delivered water and other essential elements to our planet. These impacts, as violent as they were, helped to make Earth the life-sustaining world we know today. Section 5. A moon is born. Earth's dramatic encounter with Theia. One collision, however, would change Earth forever. Scientists believe that a Mars-sized object named Theia collided with our planet billions of years ago. This impact was unlike any other. The collision was so powerful that it ejected a massive amount of material into space. This debris, caught in Earth's gravitational pull, slowly coalesced to form our moon. The formation of the moon had a profound impact on Earth. The moon's gravity stabilized Earth's rotation, preventing wild swings in our planet's climate. It also created tides, which may have played a role in the origin of life. Section 6. Cooling down and settling in. Earth's crust forms. The early Earth was a hot and violent place, but over time it began to cool down. As the planet's surface cooled, a solid crust formed, much like a thin skin on a bowl of cooling soup. This crust, however, was not one solid piece. It was broken into several large plates that floated on the semi-molten mantle below. These plates moved and interacted with each other, a process known as plate tectonics. Volcanoes continued to erupt, releasing gases from Earth's interior. These gases, along with water vapor from comets, gradually formed a thicker atmosphere. Earth's environment was becoming more stable, paving the way for the emergence of life. Section 7. Water, water, everywhere. Oceans emerge. Where did all the water in our oceans come from? Scientists believe that much of it arrived on Earth through comets and asteroids. These icy bodies, remnants of the early solar system, bombarded the young planet, delivering vast amounts of water ice. As Earth cooled, this ice melted, forming vast bodies of water. Over millions of years, these bodies merged to create the first oceans. These early oceans were likely shallow and warm compared to today's vast seas. The oceans played a crucial role in the development of life. They provided a stable environment and acted as a cradle for the first living organisms. From these humble beginnings, life would eventually spread across the globe, transforming our planet forever. Section 8. Life finds a way. The first sparks of biology. The exact details of how life began on Earth remain a mystery. However, scientists believe that the first life forms were simple, single-celled organisms that emerged in the early oceans. These early life forms likely thrived in environments rich in chemicals and energy, such as volcanic vents on the ocean floor. They obtained energy through a process called chemosynthesis, using chemicals to create food. One of the most important developments in the history of life was the evolution of photosynthesis. This process allowed organisms to harness the power of sunlight to create energy, releasing oxygen as a byproduct. This would have profound consequences for the future of life on Earth. Section 9. From tiny cells to complex creatures, life evolves. Over billions of years, life on Earth underwent a remarkable transformation. Driven by the forces of natural selection, simple single-celled organisms evolved into more complex life forms. The first multicellular organisms emerged, paving the way for the incredible diversity of plants and animals we see today. Life spread from the oceans onto land, colonizing every corner of our planet. The evolution of photosynthesis had a dramatic impact on Earth's atmosphere. As photosynthetic organisms released oxygen, the atmosphere gradually became oxygen-rich. This paved the way for the evolution of animals that breathe oxygen, including ourselves. Section 10. Our ever-changing planet, a legacy of life. The story of Earth is one of constant transformation and adaptation. Earth today is a testament to the power of life. It stands as a living, breathing archive of the countless forms of life that have existed over eons. Over billions of years, life has shaped our planet's atmosphere, oceans, and land masses. The first simple organisms began this process, gradually transforming the environment. From the oxygen we breathe to the fossil fuels we rely on, our existence is intertwined with the history of life on Earth. These resources, formed from ancient life, power our modern world. Our planet is constantly changing, driven by geological processes and the ever-evolving biosphere. Volcanic eruptions, tectonic shifts, and erosion all play a part in this dynamic system. Understanding our planet's history, from its fiery birth to the emergence of life, helps us to appreciate the preciousness of our home and the interconnectedness of all living things. Each layer of rock, each fossil tells a story of survival and adaptation. As we look to the future, it is our responsibility to protect and preserve the diversity of life on Earth. ensuring that our planet remains a vibrant and habitable world for generations to come. By learning from the past, we can make informed decisions to safeguard our future.